Assalamualaikum warahmatullahi wabarakatuh. So we are moving to the last part of this chapter, chemical equilibrium, which is the Chatelier principle. So let's start this Chatelier principle with the statement of the Chatelier principle, in which it said that if we have a system that is at the equilibrium, okay, system that has achieved equilibrium, and then it is suddenly subjected to a stress, it undergo disturbance. So the system that is initially at equilibrium will counteract by shifting to a new direction. Okay, it is shifting to a new direction, okay, to offset the stress that is applied. Okay, when it is offset the stress that is applied, and it will re-attain equilibrium position. Okay, so this is what happened if we have a reaction of A produce B, for example. So we know that initially we have only reactant. So the concentration of the reactant decreases until it reaches a point when their concentration is constant. Okay, and the concentration of the product initially is 0 because we don't have product. Okay, and then it is increases until a point it is constant. We said that when their concentration, both of the reactant and product are constant, means that they have achieved equilibrium. Okay, and then the Chatelier principle said that, okay, when the system that is already at equilibrium suddenly undergo disturbance, okay, suddenly subjected to a stress. Example of the disturbance is by the changes of the concentration. So if let's say initially, okay, when the system at the equilibrium, the concentration of B here at this point is 5 molar, for example. And then I take out half of the 5 molar, then make it 2.5. So it is undergo disturbance when the concentration suddenly drop to 2.5 molar. Okay, so what happened is the system will counteract to this stress. It will shift to the direction that will produce more B. Since that this is B, right? And this is A, the reactant. So it will shift to the side that will produce more B, which is to the right side. Okay, that is how the system counteract, okay, the disturbance. So when it shifts to the right side to produce more B, so we will observe the concentration of B will increase slowly, gradually until it reach to a point when the concentration is constant. Then we say that the system re-achieve equilibrium. Okay, that is for if we decrease the concentration or we take out any components. We also can disturb it in terms of the changes of the concentration by the addition of the concentration or increase in the concentration. For example, okay, when the system at the equilibrium, the concentration of A is 1 molar, for example. Suddenly, I add 5 molar. Okay, I add 5 molar of A until it reached, okay, 6 molar. Suddenly. It is also a disturbance. So when I reach extra amount or I have extra amount of A, what happens is the system will counteract to consume it. It will consume the one in excess. Okay, how to consume it? By shifting to the side that will use it, which is to the right side as well. So because if we want to consume A, means that we have to produce B. And then we will observe the concentration of B will decrease gradually until it reach the second equilibrium state, when the concentration is constant. Let's look at the conclusion here. If the concentration increases, the system will react to consume some of it. But if the concentration decreases, okay, the system will react to produce some of it. So let's consider this equation or this reaction to see the effect of the concentration to the system that is at the equilibrium. So we have a PCl3 reacted with the Cl2 and it produced PCl5. Now the first question, what is happen if we inject some of the Cl2? Inject some of the Cl2 means that we increase the concentration of the Cl2. Okay, so when the concentration of the Cl2 sudden increase, the system is not at the equilibrium anymore. It is no longer at the equilibrium. So to offset this stress, okay, the PCl3 will react with the additional of the Cl2. Because we add Cl2, so the concentration of the Cl2 will increase so that the system need to consume it. How to consume Cl2? By reacting it with the PCl3. Okay, so when the Cl2 react with the PCl3, so that the concentration of the PCl3 will be decreases so that the reaction will shift to the right. It will produce more PCl5. Produce more PCl5 means that the concentration of the PCl5 will increase. So the system will shift to the right to produce more PCl5 until the equilibrium is re-established. Then the second question, what is happen if we remove PCl5? Okay, remove PCl5 means that the concentration of the PCl5 suddenly decrease. So when it is suddenly decrease, the system will counteract, okay, because it is no longer at the equilibrium. Okay, so it will react, okay, with the PCl3 will react with the Cl2 to produce more PCl5. Okay, so PCl3 react with the Cl2 means that the reaction shift to the right. So when the reaction shift to the right means that, okay, the concentration of the PCl3 will decrease together with the concentration of the Cl2 because we consume both of it in order for us to get more PCl5. Then what is happen if we remove PCl3? Okay, so when we remove the PCl3, the system undergo disturbance. It is not at the equilibrium anymore. So to counteract with this disturbance, the system need to reproduce it back. We remove it, so system need to reproduce it. So how to reproduce it? By shifting the direction of reaction to the left. Okay, to produce PCl3 means that the reaction need to proceed by reverse direction, okay, which is to the left, by consuming, okay, PCl5. PCl5 will produce Cl2 and also PCl3. Okay, so when the concentration of PCl3 decreases, the reaction will shift to the left. It will make concentration of the Cl2 increase because to produce PCl3, we will also get Cl2 as well as a side product, and the concentration of the PCl5 decrease. Okay. That is on the effect of the concentration to the system that is at the equilibrium. Okay, let's look at today's sample problem. Okay, we have a reaction of the 2H2S plus oxygen produce 2 sulfur solid and 2H2O gas. Okay, this is the heterogeneous system. Be careful when you got a question, check the system is homogeneous or heterogeneous. Okay, now the question asks us what is happened to the concentration of the H2O if oxygen is added. Okay, this is H2O and this is oxygen. When the system, okay, have extra oxygen means that the system will consume it. To consume it, the reaction will shift its direction to the right. Okay, shift direction to the right means that the concentration of the H2O will increase. Okay, so this is the answer for the first one. For B, what is happened to the concentration of the H2S if oxygen is added? Okay, so it is opposite. What is happened to the concentration of the H2S? Okay, we want to see this. If we add oxygen. Okay, so when we add oxygen means that we have to consume it and the reaction shift to the right. So when the reaction shift to the right, the oxygen will needs to react with the H2S, okay, to produce or to shift to the right to produce 2 sulfur and also H2O. So when the oxygen consume H2S means that H2S concentration will decrease. And then C, if H2S is removed. Okay, if we remove H2S, means that the concentration of the H2S decrease. Okay, so the reaction will shift to the left to reproduce H2S. Then what happened to the concentration of the oxygen? When the reaction shift to the left means that Okay, it will produce H2S at the same time will produce oxygen, so that the concentration of the oxygen increases. Okay, so the answer is increase. And finally, the last question, what is happened to the concentration of the H2S if sulfur is added? Okay, when the sulfur is added, we have to remember that sulfur is solid. This is the heterogeneous system, and the sulfur is not one of the components in our equilibrium expression. Okay, so the addition of the sulfur give no effect to the equilibrium position.